This 3D diagram shows our sun and what happens when we compare its volume to our home planet. You could pack 1 million Earths inside it. Despite how overwhelmingly massive that feels, astrophysics has long operated on a comforting premise. The universe follows strict, predictable structural rules. The most important of these rules is the cosmological principle. It states that if you zoom out far enough, matter in the universe distributes itself evenly. There are no wildly dense clusters dominating one side of space, while the other sits empty. Because of that required evenness, this theoretical grid displays a hard mathematical limit for cosmic architecture. According to our physics, no single structure can exceed a length of 1.2 billion light-years. Yet, astronomers have mapped a deep space anomaly that completely shatters this theoretical ceiling. To understand why this structure defies the laws of physics, we first have to train our brains to grasp the true scale of the cosmos. We have to climb the cosmic ladder. This diagram maps our solar system from the top down. We start climbing the ladder by resetting our baseline for massive. If we replace our Sun with Stephenson 2-18, the largest known red hypergiant, its outer edge would swallow the orbits of Mercury, Earth, Mars, Jupiter, and reach all the way out to Saturn. To put that physical boundary in perspective, a commercial airplane flying along the surface of this star at cruising speed would take nearly 900 years to make a single trip around. Even hypergiant stars are tiny specks compared to supermassive black holes. Consider Tone 618. This single black hole contains the mass of 66 billion suns. This visual maps dozens of our solar systems against Tone 618's event horizon, the boundary where not even light can escape. You could fit our entire solar system inside it dozens of times over without ever touching the edges. These objects are huge, but gravity isolates them as single bodies. To find the true giants, we have to look at how gravity connects them. Zooming out to the galactic scale, our Milky Way contains hundreds of billions of stars. But IC 1101, the largest galaxy we've ever discovered, houses an astonishing 100 trillion stars. If you were to shrink the Milky Way down to the size of a city bus, IC 1101 would stretch across the landscape like an entire mountain range. Gravity's reach extends far past individual galaxies. Dark matter creates deep gravitational wells that pull thousands of these galaxies together into bound systems called galaxy clusters. The El Gordo cluster, for example, carries the total mass of roughly 3 quadrillion suns. Yet even this cluster is just a single knot in a much larger pattern. When we pull back to the ultimate macro scale, we see that deep space is highly organized. This image captures what astronomers call the cosmological web. Galaxies flow along glowing filaments of gravity, wrapping around vast, dark, empty bubbles called cosmic voids. Within this web, a single filament structure called the Sloan Great Wall stretches an incredible 1.37 billion light-years long. For a time, this was considered the maximum ceiling for cosmic architecture. Gravity takes billions of years to weave these massive networks, so scientists were confident they had found the upper boundary. Then they looked deeper. This image shows deep space data from 2013, when astronomers mapped the distant universe using gamma-ray bursts. Triggered by the violent deaths of massive stars, these incredibly bright bursts serve as perfect markers for mapping matter in deep space. While plotting these markers, the mapping team found an anomaly. At a distance of about 10 billion light-years away, there was a shocking concentration of these dying stars, packed tightly together. This dense cluster revealed the existence of an interconnected galaxy filament complex, now known as the Hercules-Corona Borealis Great Wall. This diagram compares the Great Wall, a massive structure measuring 10 billion light-years across, against our established threshold. Occupying roughly 10% of the observable universe, it is nearly 8 times larger than the 1.2 billion light-year limit allowed by the cosmological principle. Gravity requires time to pull matter together into interconnected filaments. Under our current models of the Big Bang, there simply hasn't been enough time since the dawn of the universe for gravity to assemble a structure this incredibly immense. The Hercules-Corona Borealis Great Wall is a fundamental physical paradox. Based on the time available since the universe began, it should not exist. Its presence in the deep dark proves that our understanding of gravity, time, and the evolution of the cosmos is missing a crucial piece.